Hello guys, you're welcome back to my YouTube channel, and in this video we are going to start a new series called Ordinary Differential Equations. And now what are ordinary differential equations and stuff like that is what we're going to be talking about in this video, and how we can get a differential equation from ordinary equations and stuff like that. So first of all, we are talking about ordinary equations. We are going to be talking about the order and degree of a particular equations which we need to know in this particular thing. So let's say we have a differential equation that goes something like d square y over dx square and plus dy dx plus y is equals to 0. Something like that. This is a differential equation. Into we also have something like the square y dx square all raised power 2 plus something like dy always power, let's keep something like 3 or so, something like this, equals to 0 or something like that. So first of all, in this particular type of differential equation, we need to know what are the orders of this equation and what are the degree of this equation. Now the order of an equation is the differential equation, the number of the differential equation with the highest value. Like the square y dx square is the highest here. So the order of this equation here is 2. The order of this equation here is 2, and the degree of this equation is the degree of the highest differential in the equation. So now the highest differential in this equation is the square y dx square, and it is raised to power 1. So therefore the degree of this equation is 1. So now the order of this is 2 and the degree of this is 1 for this equation right here. And now let's move to the differential that is under here. If we look at this differential, we have the y dx, we have the square y dx square. Obviously the square y dx square is the one with the highest order, and the order of this equation here is 2. In this equation we have the order to be equals to 2, and we have the degree of this equation here, which is the degree of the highest order raised to power 3. So therefore our degree here is equals to 3, and that is like the basic stuff on order and degree in a differential equation. So now let us move on to differential equations. So first of all, um, before we can get something like this, we usually have it as our basic form of equation, something like y is equals to ax plus b plus c plus ax squared plus bx plus c, any type of equation, something like this. An equation like this, which are the ordinary equations, can be converted into differential equations. So now let us see how we go about it. So now let's say we are given these ordinary equations that is here on the board. We are given these ordinary equations here, and now let us try to solve them. The first one here is y is equals to ax plus a squared. Now, if we are to turn this normal equation into a differential equation, what we have to do is we differentiate both sides. So if we differentiate, we have dy dx is equals to, when we differentiate this, we get it as a, and this will be equals to 0. So from here we can just put the 0. So if our a is equals to dy dx, therefore anywhere we see a, we put dy dx. So our y is equals to dy dx of x, and we have plus dy dx all square. So now this here is a differential equation, and this is the ordinary equation. We converted this ordinary equation into its differential equation. Now let us try the second one over here. We should try this now. It says y is equals to a cos x plus b sin x. So now if we do y equals to a cos x plus b sin x, now we differentiate both sides. We are going to have the y dx is equals to, now if we differentiate cos x, we are going to get minus sin x. So we are going to have this as minus a sine x, then we have plus, if we differentiate b, sine x is equals to cos x, that is b cos x. So now we cannot yet impute this into this, so we can decide that we want to differentiate this the second time. So we're going to have the square y, the x square would be equals to, differentiate sine x, we get cos x, so we have minus a cos x, and here we are going to have cos x is equals to minus sine x, so we have minus b sine x. We can bring our minus outside here, we have a cos x plus b sine x, and this here is equals to this here. So therefore we have known that our dy dx is equals to, our dy dx is equals to everything here, the negative of this. So we can put minus the square y, the x square is equals to a cos x plus b sine x, and since a plus x plus b sine x is here, you can say that y is equals to minus the square y d x square. And now here we have successfully converted an ordinary equation into a differential equation. Now we can try to look at the third one over here. If we look at the third one over here, we will see that this is y squared. So y squared plus ax squared plus b y squared is equals to ax squared plus bx plus c. And if we differentiate this, because this is going to kind of like give us an implicit function if we are going to have to differentiate y here. So we are going to be having 2y dy dx over here. And then if we continue our differentiation here, this is going to give us, if we differentiate this, we have 2ax here, and we have plus b as what is here. That's just going to give us in the first place. Now, if we want to differentiate this in the second place, we are going to treat this as products of each other. So we differentiate 2y multiplied by dy dx, and we differentiate dy dx and multiply by 2y. So here we are going to be having, differentiate 2y, we are going to get 2 dy dx, then you multiply it by another dy dx, which is the one that was there before, and then we add it with, if we differentiate, we add, multiply 2y, if we differentiate this, you get the square y dx square, that is for this side. And if we differentiate the other side, you are going to get 2ax, which is equals to just 2a. And you see that 2 is common in all the sides, so we have 2, 2, 2. So they just cancel each other. And we are going to be having dy dx here, all square, plus y, the square y dx square is equals to a. So now we have known that this here is equals to a, and therefore if this is equals to a, we know that our b here, from this equation here, you know our b is equals to 2y dy dx, and if we bring 2, that is minus 2ax. So now we know that a is this, so we impute this value of a into this particular point here. So therefore we just have 2x into brackets everything that is here, which is dy dx all square, dy dx all square plus y the square y dx square. Now this is our value for b, and we have gotten our value for a and our value for b, so we just impute them into this equation here. So we know that our y square is equals to, what is our a here, the y dx all square. Now we have plus y the square y the x square here of x square here, and we have plus b. We have our b. Now you see our b here, and our b is everything that is here, so we just know that that is um 2y, the y, the x, minus 2x into big brackets here, the y, the x all square plus y, the square y, the x square, which is what is here, and then we close that bigger bracket. This is our value for b here, and our b has x, and we have plus c. We can go on to simplify what is in this particular equation here, but this is what our differential equation is, and something like that. So now that is how to get our differential equation from our ordinary equation and stuff like that. Thank you.